Hello and welcome to a brand new devlog for Dark State Brightest Night. Couldn't be bothered looking up which one this is. Just check the title. I'm fairly exhausted, so I'm gonna keep this as short as possible. The devlog was meant to come up 1 to 2 weeks after the previous one, but clearly this didn't happen. Reason for this is that I knew that I was going to be extremely busy after those initial 2 weeks. So I wanted to finish up the enemy AI before that. I had a clear idea of what I needed and how to do it, and I expected it to be done within those 1 to 2 weeks. But oh, I was so wrong about that. Yeah, this turned out to be a pile of burning garbage to work with. So, since after those 2 weeks I've been rather busy with a bunch of different stuff. I got myself extra part-time work, in combination with my freelance work. So yeah, overall I've been fairly busy. Haven't been feeling too great lately either, so... Regardless, let's get started on this project. So, first of all, what do I need? I need an pathfinding system that allows my enemies to find the player, basically to have them go from point A to point B. The algorithm it uses is going to be either A star or dijkstra. Can use either one, doesn't matter that much. Lots of documentation online on those, they're easy to implement. I had one implemented, which is currently not functional because of, well, I'm currently working on it, but pathfinding algorithm itself is not an issue. The issue comes with the system it runs on. So basically, a pathfinding algorithm works with a very specific data structure, namely a graph, which is basically a bunch of points, locations, and then connections between those locations. And if you're working with a bit more advanced pathfinding algorithms, like a star, you also give a specific cost or a weight to those connections, basically how much it costs to go from point 1 to point 2. This allows the algorithm to find the shortest possible path in a graph. Now, most platformers are tile-based, meaning that their level design is basically a grid of squares, and every single square within that grid would represent a node within the graph, and it would be connected to the squares in the cardinal directions around it, and the pathfinding algorithm would just run on that fairly easily. Basically starts on the square your enemy is on, and checks all adjacent squares to form a path to the player. Even though my test level is currently kinda graph-based, this is not how the final level design will look like. It's gonna be a lot more organic, a lot more slopes, fluid shapes. So I'm instead working with a node system. A node system resembles more closely a graph, in the sense that it is literally locations that contain a point, and then connect to other nodes. If you have a very simple platformer, you could just place these in the level and manually have the connections between them. But considering the amount of levels I want to go for and the average size of them, I am forced to automatically generate these and their connections between them. And that's where the issue lies. So, the idea I had to do this was rather simple. The nodes, they would be automatically generated eventually. Generation code itself does not matter. That's a problem I'll tackle later on. The biggest issue was to have the connections between two nodes automatically made, so that the algorithm could function on my set of nodes. Because, for example, the node here cannot connect to the node there because there is a platform in the way, so it's impossible for a character to move through that. And that entire system turned out to be a lot more complex than I anticipated. Started off with a very simple idea. I would have the nodes connect to the the closest nodes around them. some people use a maximum range for connections, but because the nodes are automatically generated, or will be, and I have no idea what generation method I'll use, I cannot expect nodes to be within a relative distance of each other, so that's not an option. So I just had them check for the closest nodes near them, and if there was another path between from that node to another node that was shorter, it would destroy its own connection. And that obviously did not work, because it resulted in the nice phenomenal bug where one connection between two nodes would not be made, and the entire section of nodes would be split into two different node chains that weren't connected to each other. That's a big no-no. So I redesigned the entire thing, and I also implemented zones. A zone being an area that I designate, and all nodes within a zone will have a path to each other. If two sections of node have no connection between each other, they are to be put in different zones. This is gonna make it a lot more performant, and we'll be able to lock enemies to a specific zone. So the next thing I did was, what you see here. Basically had the nodes check for collision between them, if not, make connections. I threw away the code that made sure to only connect to the shortest ones, because I was like, why do I need to do that? Well, the only reason I did that is, like you see here, 3 nodes in a row. Node 1 should connect to node 2, and node 2 should connect to node 3, but node 1 connecting to node 3 would be redundant since there's a path through node 2 that is perfectly viable. However, with the code I have now, it also makes a path between 1 and 3. And that's what I wanted to avoid. When it came to me that the pathfinding algorithm itself already checks for the shortest path to a certain location, so it functions on this, it's just a little bit less performant. And the abode of performance loss created by this isn't that extremely big that I'm forced to change it. So I continue to work with this system. Then I came across another issue, which is moving nodes. Certain nodes will be dynamic and move across the levels, for example moving terrain, or for example the enemy and player are each counted as a node, but they move freely between terrain, between sections of each zone, and the player even moves between zones. So I needed code to add them to a chain of nodes, or remove them from a zone in the player's case. The whole zone section was rather easy to implement, but adding a node to an already existing node section means that you have to check every single connection again. Because if I started here and a node was placed here that connected to these two, but if I move over here, a viable connection could be made between the player and this node over there. Which means that I'll have to update the entire zone that it happens in. And if you have to do that with dynamically moving entities, and then run an algorithm on all the different paths created, especially since redundant paths are made on top of those, the performance loss becomes too big, and it causes a lot of different bugs as well. So since then I've been working on an algorithm that would basically do a breadth first search through the graph. It would select a node, it would then find the closest node to it, check all the connections to node it shares with this node, and if the path through them is shorter or equal, it will delete its own connection. So for example, on the bottom row, this node here will check for this node for connections that it shares, which is node 3. It will then calculate and discover that the distance between node 1 and 3 is equal to the distance between node 1 and 2 and 3, so it will delete its own connection to node 3. It will then do that for all of the other nodes within this shortest node, and then jump to the shortest node from this second node, which is not, as long as it's not itself, which would be node 3. Node 3 would then do the same for node 2, check for all connections, and that should... It might require a bit more tweaking, but this is the general idea, and that should prevent redundant connections to be made. This also means that I can simply have an entity connect to the closest node to it, rather than having to connect to the entire graph at every possible node position. That's basically in short what I intend to do. And that seems extremely simple on paper, but the actual code itself is annoyingly complex, which is severely slowing down progress on this. I have to make a bunch of different functions for the algorithm to use. I have to make sure that the order in which everything is executed is correct, because the nodes get spawned in as objects, but I do not want them to remain objects during runtime, so they're almost immediately deleted after creation. But before they're deleted, I need to run the two algorithms. First is going to be a root connection algorithm, which I'm currently working on, which will do what currently every node already does, but this time for the entire zone. It would connect all the nodes that have a viable connection. After that, it would do a more precise connection check and remove all the redundant connections, cleaning up the entire graph. And then adding or deleting an extra node from the graph should be fairly easier, as you only need to connect to a single node in order to be connected to everything else. It's also going to make the algorithm itself a lot more performant. So yeah, next devlog will be when I'm finally done with this. I have no idea when that's going to be the case, so expect another couple of weeks, up to a month, before another devlog is released. Yeah. Anyway, I hope to get this up and running as soon as possible, and I will see you all in the next devlog. Take care and goodbye.